Okay, so today we're going to be looking at the final part of uh, our work with 5.4 today, finding um, uh, normal distribution if something is normally distributed and the percentages and using the normal distribution. So this will be day 3. And what we're going to do today is I'm going to show you how to use Desmos. So we're going to take a larger group. Here we go, move that over. We're going to take a larger group of data and we're going to find out whether it's normally distributed or not. And how we do that is we find the standard deviation and the mean, and then we basically work from that to see if it fits into the percentages of the normal distribution or close to it. So basically we're just comparing, okay? And we're going to be using our data ranges for seeing if something is normally distributed. It's going to be find the mean, then we're going to go one standard deviation away from the mean, then we're going to go and find the percentage and see what that is, and then we're going to do two standard deviations from the mean, find the percentage, see what that is, and by that calculation we can find out whether it's normally distributed or not. So let's do an example like that. And first thing I'm going to do is we're going to use something to speed up finding the mean and the standard deviation. We're going to use Desmos. You can use a graphing calculator to do it, but I know how to do it on Desmos because that's what I use most of the time. So what we're going to do is we're going to use a set of data here. So I'm going to pick a set of data from whatever sets I have here, and we're going to do that. So let's hide this and we'll set this up. All right, so analyzing, solving problem. Let's go with a little bit smaller type here. Okay, so this is the last day of 5.4. Finding if some data is normally distributed. So the first thing that we got to do is we got to have some data. So let's do an example here, and then we'll go through the steps. Is the following data normally distributed? Question mark. Okay, so let's come up with some points here, and I'll see if I can find one that is not too long here as an example. You don't want to do that one. You want to do some. Okay, well, let's just go with the following grade point scores. Okay, so I'm just going to do a line of what we got, 3, 6, 10 here. We'll do 2.0, 2.4, 3.3, 1.7, 2.5, 3.7, 2.0, 2.3, 2.9, and 2.2. Now we could go ahead and figure out the standard deviation. It takes a while by doing it by hand. So we're going to use Desmos. So the first step, step 1, use Desmos to calculate your mean and standard deviation. So we're going to bring up Desmos here. I will just pop it over here and slide it over. Okay, so graphing calculator Desmos works pretty good. So the first thing you've got to do with Desmos, and I'm just going to slide this over to the other side so I can see the data. Okay, the first thing we're going to do is we're going to insert a table here. Okay. So we go up into here, this plus part here, and we want to insert a table. Okay, and under the X1, we're just going to put our numbers in that we had, 2.0, 2.4, and 3.3, and 1.7, and 2.5, and 3.7, and 2.0, 2.3, okay, and 2.9, and 2.2. Okay, so there's our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. Data. So now we have to go into the function menu, which if you click on this keyboard thing here, it's right in here. Okay, and then there's your trig functions, there's your miscellaneous functions, but we want to go to stats. That's what we're doing. And we want to get, let's do, in here, we got to click in another box, second box. This is our table. We're going to use this X1 variable, and we're going to do a mean. So we're going to click mean, and then we're going to type in X1. It's X underscore 1 of this data with the bracket. So go X, and then you can hit the shift underscore to make it go down like that, and go 1, and close the bracket. So my mean is 2.5 right here. Okay, then we click another box. So we now know it's 2.5 for our mean without doing too much other than typing our data. Hit functions, and standard deviation is this STDEV thing. So click that, and then go, okay, X1, X shift underscore thing at 1, and our standard deviation according to this is 0.6 235, whatever it might be. So that's our first step. Once we have that, we have our standard deviation, and then we can see if this fits into it or not, into the normal distribution. It's kind of a small set of data, so it probably won't, but we'll see. So we'll bring our Blackboard back. And so we calculated that. So we had the mean was equal to 2.5. And let's just kind of round the standard deviation off so it works a little better here. We got 0.625. You want to go 2 decimals? I guess we should, because it's such small numbers. Go 2 decimals. So that was the mean. And the standard deviation was equal to, let's go 0.625 would be 0.63. Should be good enough. Okay, so what we got to do now is kind of come up with some ranges of, we'll look at the ranges, 1 standard deviation away on both sides, and then 2 standard deviations away, and calculate the percentage of data that's in each And if it kind of fits with what it should be, then we'll be all right. So step 2 is to create ranges, categories if you like, that are standard deviations away from the mean. Okay, so for example, if I get my marker out here. Okay, so us, for our values here that we have. All right, so if I take this and make a marker. All right, so the range, the mean is, okay, so the first one we're going to do is the mean minus 1 standard deviation. It's not a 6, it's a standard deviation symbol. Okay, so kind of like this is a better one. A little tail on it, a little bomb there. Okay, so this is going to be equal to 2.5 minus 0.63, which equals 1.87. And then we're going to do standard deviation plus a mean plus standard deviation. So that's going to give us that middle range. So this is going to be 3.13. So our first range from 1.87 to 3.13, we should have 68%. According to the standard deviation table, if you look on page, where is it again? 250, I believe. Between 1 standard deviation, 2 standard deviations is 34% on both sides. So it should be 68% of the data. Okay, that'll be our first check. We can do the same thing with 2 standard deviations. So the mean plus 2 standard deviations. So 2.5 plus, okay, this would be 0.63 times 2. That'd be 1.26. So that ends up being 3.76. Or, yeah, 3.76. What am I doing here? Having a brain cramp. There we go. And then the mean minus 2 standard deviations would equal 2.5 minus 1.26. So in this case, this would be 1. What would that be? 324. Okay, so this one's going to be 2 standard deviations away from the mean and 1 standard deviation. So this range would be from 1.24 to, what is it here? 3.76. Okay, so it's a bigger range than this one, obviously, and that's going to add in 13.5%, 13.5%. So this should be 95% of our data. Okay, and we'll just do those two. If we get a yes on both of those, we should be good. So then we analyze our data now from 1.87 to 3.13, we're going to have a data set out of 10. It's only 10, so it's not very many. But if we look back at our points, we can go to our table on Desmos or look at our points and see how many fit into between 1.87 and 3.12. So this would be 1, 2, I got 1, well, I should check them off so we can see. Okay, so how many are between 1.87 and 3.13? 1, okay, 2, that's too big, too small, 3, too big, 4, 5, 6, 7. So 7 out of 10, which equals 70%. Oh, that's pretty close. So we got to do another check. Let's see if the 95% works. So between, because it's such a small set of data, it's so small it's hard to tell, but between 1.24 and 3.76, we should have 95%. So it should be a 9 out of 10. Or it might probably be all of them. So 1.24, so we'll check them underneath. Yes, 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 yes. Just barely yes. So they're all there. So it's 100%. So that's it's kind of normally distributed. So this is 10 out of 10 equals 100%. So, and then if we did 3 standard deviations away, obviously, would be all of the data would fit into there. So we could check 1 standard deviation above to see if it's 34 on each side as well, because we're not too sure. So we could just check one side of it. We could say, well, what about if we just go, let's just double check and see from 2.5 to 3.13, that should be 34%. Okay, let's see how close that is. 2.5 to 3.1. 2.5 to 3.1. 1. 2. So that's only 2 out of 10. 20%, and it should be 34, right? And this one here, if we do underneath it, the 1.87 to 2.5, that's going to end up being 5 out of 10. So it might. So let's see, 1.87 to 2.5. 1, 2, 3. Wow, that one we counted already. 3, 4, 5. So that's 5 of them, which makes sense because we had 7, right? But I just recounted to make sure. So that's 50%. So this is supposed to be 34 and 34. So I'm going to say like this was close here and this was close, but I'm going to say no because these ones should be 34 and 35. It looks like it's kind of more towards the lower end. It would kind of go like, and then it would come down faster there. So it's not perfect. So we can say no, not normally distributed. It's close, but not quite. Okay, and you can use Desmos to help yourself out there as well. And so that's basically what you do. So step 2 is create standard deviations away from the mean. And I guess step 3 was to check to see if the percentage match up. Check to see if the percentages match page 250 when you check the standard deviations away. So that's the last type of question that they give you. So I'll give you a couple of those to do. So on page 251 again, and 250 up to 252, you can do 4 and 9. Okay, 9 has a lot of them, so you might want to use Desmos to type them in. Okay, and you can also do it when you have ranges as well, but we won't bother doing that. We did that in a previous one. So that ends section 5.4. So the only thing we have left now is Z-scores, which should be a couple of lessons, maybe 2 lessons, maybe 3, depending on how I split it up. And that'll be kind of it for the stats unit. And then I'll give you a little bit of a hand-in type thing so I can see how you're doing. Or maybe I'll just get you to do, I can use a workbook or something like that. And then we'll go on to the next unit and do that one. And it's kind of the other 2 things jammed together. Okay, so I will stop the video at that point there, if I can. There it is. So that was about just over 20 minutes. Okay, so good luck with that one.